Hey everybody, I'm Zac.
And I'm Jesse.
And you're watching In Depth.
On Now You Know. We're brought to you by abetterrouteplanner.com. Use our link in the show notes below to get a 30-day free trial.
And we're sponsored by BigBattery.com with the best battery prices in the USA, guaranteed. If you've got something you need to power, from homes to cars, RVs to boats, and much more, BigBattery.com has you covered, offering the newest battery tech. Use the code NOWYOUKNOW to save 5% off your purchase today at BigBattery.com.
And we're brought to you by EcoWare.us. We have new designs that we design every single week, and they are all designed with solar energy. And on top of that, we carbon offset the production, the shipping, and the life cycle of every product, and we plant 10 trees for every order, so it is extremely carbon negative. So if you want to find the shirts that Zac and I are wearing, along with dozens and dozens more, you can head over to ecoware.us.
All right, so I have to pinch myself sometimes. I have a job where I get to meet some of the smartest people on the planet, people who are changing the planet for the better.
How do we meet these people? It's because of you. Not only does watching and subscribing to our videos means that people take us seriously when we reach out to them, but you are like our little detective agency.
Yeah, a worldwide detective squad, uncovering stories and discovering companies that we would have never known about.
Case in point, the company you are about to meet, Polar Night Energy.
Now, Polar Night Energy is a Finnish company that, I have to be honest, I probably never would have heard of if it weren't for one of our awesome community members from Finland who reached out to us a few weeks ago and said, hey, check out this company. They're doing something really special.
So Zac checked out their website, and I think you just kind of got confused.
Yeah, I mean, nothing really made sense to me. I thought this is either way oversimplified and these guys are like in some kind of stealth mode and they don't want to tell the world anything, or, well, I showed you the video they had, and what did you think?
I kind of thought the same thing. I'm like, okay, these guys are an energy storage company, but how does this work? I see power coming from wind and solar, and then it goes into the ground, and then it powers a city. I didn't get it.
Yeah, now Jesse and I are pretty skeptical when it comes to companies' claims.
We get pitched things all the time. Our company is working on a solid-state battery. It's going to change the world.
But with a little digging, you either find a fatal flaw,
or you find that it's complete BS.
Or often it's a good idea, but it's just not economically feasible and probably won't be for quite some time.
And there's nothing wrong with that, but this shows our mindset when we approach new companies.
So I reached out to Polar Night Energy. I scheduled a meeting, and it took me about 6 minutes to realize that I had missed it. It had gone over my head. Their idea is so simple and elegant and so, I don't know, obvious. I ended up hanging out with Marku, Lisa, and Tommy on that call for like an hour as they helped walk me through their technology and how they founded their company. And I was so pumped after that call.
And then Zac told me about the call, and he was really excited, and he said, wait till you meet them. I think they've got an amazing solution to energy storage. I was interested to hear their idea, but I was also still pretty skeptical.
So here's a taste of our interview with Polar Night Energy.
But before we drop you in, I think it'd be helpful to explain their technology. Because if you're not used to a Finnish accent, it can be difficult for people to understand. And I don't want you to tune out and miss out on the whole point of this, which is really amazing.
Yeah, it would be helpful to just outline what we're about to talk about so that our conversation will make more sense going in.
So the first thing is sand. And you might be like, what? They store energy in sand. And it's not a chemical battery. They don't treat the sand with any kind of sprays or chemicals or anything like that. It's just sand, and that's it.
Now, I remember interviewing Donald Sadoway from Ambry, and remember what he said about batteries.
I like to say if you want to make something dirt cheap, make it out of dirt, and preferably dirt that's locally sourced.
Okay, so as cheap as dirt, but wait, they're actually using dirt. So how do you store energy in sand?
And the answer is heat.
All right, so I get that they heat up the sand to really hot temperatures, 600 degrees Celsius. Where do you get the heat?
Renewables.
So wind and solar.
Yep.
But wind and solar, as far as I know, makes electricity. How do you turn electricity into heat?
I mean, you can turn electricity into heat through resistive heating.
Yeah, but that's super inefficient. I mean, everyone knows that if you heat your house that way, that's like the least efficient way to heat your house.
Well, no, it's not physically inefficient. There's two different things here. A lot of people say, well, it's not efficient. It's not cost effective. So on a typical grid, if you're paying consumer prices for your electricity, which if you own a house, you are, using resistive heating to heat that house typically isn't as cost effective as simply having, natural gas piped to your house, or, a big tank of propane in the front yard, or in some cases, even burning wood. Not as cost effective, but if you take electricity and you turn it into heat, it's 100% efficient, because that's just the way electricity works. It's 100% efficient.
Yeah, and that's where I got caught up because I kept thinking, like in a gas engine in an ICE car, we talk about it all the time, that most of the energy is lost in heat. It doesn't go to powering the wheels. And I was like, see, so that's inefficient whenever you have heat. But in this case, what you're saying is
Heat is what you want.
Heat is what you want. Okay, so fine. You got your heat. What do you do with it?
You can heat buildings with it.
Okay, but that sounds really complicated.
Well, it's not that complicated. In fact, many cities around the world already have the infrastructure to do this.
Infrastructure?
So there's this thing called district heating, and the way that it works is, you have your utilities that come in, like your water, and you have sewer going out, and you have electricity coming in. Well, you'd have another set of pipes coming in that would be for your heat.
Oh, okay, but that's why this company's in Finland, because only Finland has this special pipe system.
Well, that's not true. I mean, actually, New York City, St. Paul, Minnesota, and many other places have district heating in cities.
Okay, but that's just heating buildings. So these guys have figured out a way to heat buildings, but that's not powering the electrical grid.
Right. They don't turn the thermal energy back into electricity. But if you want to have a 100% clean grid, heat is going to be one of the hardest problems to face because heat takes a lot of electrical energy to generate. That's why we've been burning stuff this whole time. It's because, you burn something, it completely goes away, and all of that heat, oh, great, I could use it. But when you're talking about generating that energy with solar or wind, and usually like with solar, you're not generating it when you need the heat.
Okay, but we don't need heat every day. I mean, there's a lot of places where we don't want heat practically at all. Like Texas, you only want it like 1 month out of the year.
And that's why this is energy storage. And the amazing part about it is that you can store this heat for months, if not years.
Okay, so wait, you can store the energy that you make with solar and wind for months in, say, the summer, and then use the heat later in the winter when you need it?
Exactly. And that's why I think this idea came out of Finland, because what do you got to do in Finland? You got to prepare for winter.
Oh, and that's the name of the company, Polar Night Energy.
Right.
Like they have months and months and months of darkness.
And so unlike here where it's like, the solar is a little bit worse, there might be no sun in parts of Finland. So obviously you need to store some kind of energy, and this is a really, really cheap way to do it.
Okay, but I spotted a problem.
Okay.
Which is this is a startup, and startups take years to build out all the factories and stuff they need. And so it's going to be years before we get this technology.
No, they already have factories all over the world.
They're a startup. How do they have factories all over the world?
Because nothing that they're making is that complicated. They need pipes, blowers, pumps, valves, resistive heaters, all of these things already readily available everywhere.
Oh, wait. So they don't have to spend all this time, building out factories. They're ready to go.
Exactly. The way that the system works is that you basically have a bunch of pipes full of air in sand. And then you simply heat up some air, pump it through the pipes, which heats up the sand. And then the sand is a great insulator. And in fact, you can also insulate the sides of whatever sized system you're doing.
Aha, I've got the problem.
Okay.
This must take up a huge amount of area. So cities are going to have a whole city block taken up by a big building full of sand.
Well, no, because you can just dig a hole.
Okay, but then you're stuck with a huge empty field.
But you can build something on top of it that you'd like. And in fact, it would be a little bit warm.
Like what?
So like, say a playground or a greenhouse, you could have in the winter, it snows and stuff. Just magically, the snow doesn't seem to stick. And this one area where you have below it 600 degrees Celsius sand.
All right, we should probably get to the interview so you can see this for yourself, because you might be saying the same thing I said, which is this sounds too good to be true.
Hi, I'm Tommi Eronen, co-founder and CEO of Polar Night Energy.
Hello, I'm Markku Ylönen, co-founder and CTO of Polar Night Energy.
Hello, my name is Liisa Naskali. I'm project manager at Polar Night Energy.
All right, right off the bat, let's just ask, what is Polar Night Energy? What are you guys up to?
We will be heating sand up to 600 degrees Celsius, which is really, it's a way to revolutionize the energy sector, because scaling up renewables really requires large-scale efficient solutions of taking in electricity whenever there's huge loads of excess available, for example, from solar and wind. So there's no good addresses for these high power demands, and our storage can take it in really cost efficiently.
Okay, hang on. Wait a second. Wait a second here. We've been doing this for a while.
Yeah.
We heard a lot of plans on how to store energy. We got, your lithium-ion batteries.
You got different kinds of batteries.
We got hydropower.
Right, we got molten salt, and you're telling us that you're just going to heat up some sand. What are you doing with hot sand?
Yeah, it's the thing. Like, if you want to make a dirt cheap battery, you have to make it out of dirt. This is a quote from the one guy who is making the metal battery.
Wait a minute, you're right. So Donald Sadoway from Ambry said if you want to make a dirt cheap battery, you got to make it out of dirt. You guys must have either...
You took that really to heart.
Yeah, you took it literally. So you made it out of sand. So you must do something special to the sand, right? You must be, you're oversimplifying, right? You must be pulling the sand apart and making it to nanostructures.
You're putting electrolytes into the sand.
Yeah, there's no need of any special treatment. Actually, we even want to take sand that no one else wants.
Yeah.
So even the construction industry has some standards for sand. So we have no real standards as long as it's like not super coarse or there's no burning stuff in between the sand grains. So just cheap enough or like even zero cost medium for storing energy.
Yeah.
So it must be dry, but that's the only requirement we have for our sand.
And it will be dry after we heat it up. And I was saying that same thing as you interviewed Highview Power, the liquid air storage. They also said that we didn't have this problem earlier in the energy sector because there wasn't so much of renewable fluctuating power production.
I think a lot of viewers who are watching right now might be a little confused because they're like, wait, so pipes in the sand, you create this heat in the pipes, and then they might be thinking like where I live, there's nothing that we can do with that. But what you're saying is where you are in Finland, in New York City, and in many other places of the world, there's actually district heating, right? There's pipes that are throughout the city that actually heat buildings. And I think a lot of us don't know that because it's hidden and we just think like the buildings are magically heated. But you're saying there's a power plant somewhere that has to heat up that water or steam and heat those buildings. And what you guys can do is just hook into that system and feed all those buildings heat.
Yeah, that's correct.
Exactly. Yeah.
And so then I guess the question is, what are those, heat power plants? How are they generating the heat?
They are usually burning stuff, and that's the really key thing here, that we really have to make systems in the future that doesn't burn anything, even wood.
More than 90% at least of the heat generated in industry to build heat buildings, they burn something, natural gas, oil, wood chips, peat, anything. And we really want to replace all of it, or at least almost all of it, if we want to have any chance of meeting any climate goals.
Why sand? Why not something else like, I don't know, water? Because water can hold a lot of heat, right? Like, that's the cool part about water. So why not just heat up some lake somewhere?
Yeah, that's a really good question. And we have also, when me and Markku, we have calculated this thing like almost 10 years now. And we started with water-based solutions, and we were thinking about those. And I made my master thesis about them. And later on, we realized that clean electricity production and solid material is the way to go. One thing is also, when you interviewed the company that made a wooden wind turbine structures, it's when they found out that you can't just look a one number in a bigger problem. You have to combine all of those and look the whole thing. And it's same thing here, that if you look out the energy equation, it tells that density times specific energy times temperature difference, it's the energy per volume that you want the highest possible number. And actually we are like around 3 times better than water in that number, because we have so big temperature difference the last term in that equation.
And with water, you could only go up to 100 degrees C, and then you don't have any more water.
Yeah, basically 95 is the maximum because you really don't want big pressurized systems that it would need.
So by using pressurized vessels, you could go much higher in temperature, but we're now really talking about large-scale systems, which means like thousands of tons of sand. So dimensions would be in tens of meters rather than small containers. So building pressurized vessels that large, it's not really doable, at least not cost efficiently.
Well, let's talk cost here. So, I mean, if you're going to have a business, you got to have the lowest cost usually, or a very competitive cost. Sand, that sounds great because that sounds practically free, but there must be some other really expensive part of what you're talking about that you haven't told us about yet. So where's the expensive part you're hiding?
Yes, the sand is quite cheap, but we have a lot of pipes. Those are one expensive part. But when we are talking about big systems and not maybe the cheapest solution, but the most reasonable solution, then we are compatible with other kind of solutions. And we believe that in the future, it is not as cheap as it is now to combust things.
So how do you make something like this?
There are several ways to do that. So for smaller systems, it is possible to build up a cylinder, for example, steel cylinder, and fill it that with sand and pipes, and that is above the ground. But then with really big systems, it is possible to dig it in the ground. So we can do it below the ground, and for example, for some canyons or something like that, so we get the benefits from the natural shapes of some.
Yeah, or even like used mines, we could fill with our systems. Of course, if the shape is about the correct one, it's not really that sensitive. We want to work with shapes close to cylinder.
You could think that the size is like huge, but it's not so big because we are now in Tampere, Hiedaranta, and they are planning to make here buildings for 35,000 people, and we calculated that what size of the storage they would need here, and the cylindrical storage would be around 40 meters in diameter, and was it 25 meters high. So I think that's quite small for 35,000 people.
Okay, so I'm just trying to picture it. So you basically, you can either put it in a cylinder, you can dig underground, and then you put in all these pipes, and then you just fill it in with sand. Sounds less complicated than putting in a pool.
We won't have sand escaping. That's the one benefit also about solid material. With water, you might even have it escaping at some point. Of course, we'll have to build some insulation materials, but the bigger the scale, the less significant the insulation will be. We will want to have about like 0.5 meter to 1 meter of insulation material around the storage. So there's insulation material, sand, pipes, of course, some electric appliances, but nothing buried inside sand. So it's really simple. And what's even surprised us a bit that we got a good patent for the system. So our closed loop heat transfer system, that's basically the piping.
And so the bigger you go, the more efficient you get, because essentially you'll get more volume per surface area, and surface area is not your friend because surface area is where you're losing heat, right? So like, let's say, we heat all this stuff up and then we, it's up to 600 degrees and then we just leave. We don't take any heat out of the system. We all go on vacation. That no one's using it or anything. How long until it becomes, down to an unusable temperature?
If we make some scale for it, let's say that it's the same 40-meter storage, so it will be there like months and months.
Months and months? What?
It's a seasonal storage that we are talking about. Yeah. So season means, of course, that we can take in solar energy also here in Finland, and we can store that from September to March.
So that's why you're called Polar Night Energy, because you're up in Finland, and in Finland you don't get a lot of solar energy in the winter, and so you want to store this energy over the course of months.
And
yeah, that was the point in a name that we wouldn't have people laughing at us. Have you realized that there's no sunshine in Finland when you need the most of the energy? So that's in the name.
yeah.
Now, it sounds like you guys are really smart. You've worked this all out on paper. That's great. I suppose you probably haven't actually made this yet, so how do we know it really works?
Yeah, we have made it. We have a working pilot plant here next to us, and actually when we are turning a switch there, it will heat this building next to the pilot plant. And also this summer we are building next like a commercial pilot with a district heating company in Finland.
So Tommy, earlier you said, you actually quoted Donald Sadoway. He said, if you want to make a battery that's dirt cheap, you have to make it out of dirt. And you obviously took that quite literally, but I'm thinking of his battery system, which is a molten liquid battery, which means that the batteries themselves have to be at 600 degrees Celsius, give or take, in order to actually function. And your system functions around 600 degrees Celsius.
What are you saying?
Do you think that there's a bit of a collaboration there to where his batteries produce excess heat and have to be stored at excess temperatures, and your system takes advantage of stored heat? Could you have in the center of your sand battery Donald Sadoway's battery, so you could actually be doing electricity and heat storage?
Yeah, definitely. I think there could be something that we could do together, and of course you have to have a storage for heat and also storage for electricity, and also those the liquid metal batteries were super interesting, and also the high wave power plant, it's super interesting also.
Yeah, and it's really like you have to combine all these possible solutions. They all have their advantages. Our advantage would be the bulk storage. It's cheap enough, and still the heat stays in a useful form. But then to really make the systems work, we want to work with everyone. Like heat pumps, storage is one like key idea in our storage is that it's really compatible with any other solution. Just plug in and start collaborating.
So let's talk about scale for a second. You're at the part of your company where you're ready to scale, it looks like. And for many companies, this is a difficult part because you have to start building factories. But you talked about sand and pipes. So I don't think you have to build factories.
And that's a really big thing, that we don't have to build our own factories, and that's why we didn't have to raise that much money from business angels that we have already done. And we can now actually start with a pretty close-made product.
We have made the system so simple that metal workshops of like standard quality can make our systems, the piping systems, and then it's just like excavation work or rather simple construction work. So we want to always work with the local workforce and subcontractors. So if we would like build in the USA, we would just search for local workshops that could help us and make it there. So we don't need our own factories. Of course, the automation and parts like that will remain our design, but the physical parts can be built anywhere.
Wow. Okay, so walk me through this. You guys it seems you've known each other for a long time, right?
Yeah.
Yep.
And so you started as students. It sounds like some of your papers in school were about this topic, and you must have. Walk me through it. Like one day, were you sitting in a dorm room somewhere, and you just were like, "Hey guys, we could heat up sand."
Yeah. Me and Markku, we were studying the same thing, power plant technology, which this is, and we were talking about to build a hippie commune for engineers, and we would want to know how to build a blockhouse for us that would be energy self-sufficient. And that's like quite hard thing to do in Finland.
Yeah, I think Tommy had this idea first, and probably he asked something from me that, hey, I have a problem, you probably can answer me.
Yeah.
And then I really got into well, that's an interesting problem.
Yeah.
Let's solve. Let's talk over coffee. Of course, in the beginning, at some point we realized that we've been spending thousands of hours in talking, modeling, and planning this.
Yeah, and first I made my master thesis about it because I have done the COMSOL multiphysics calculations about the system at that point, like 2,000 hours, and I really want to use that on something.
I have known Tommi since we were teenagers, something like that, and I can tell that he have plenty of ideas, different kind of, mostly technology-related ideas, and I were listening many kind of ideas, but then he repeatedly talked about that same idea, different kinds of how to store energy and how to produce it a sustainable way and so on. And then he finally sent his master's thesis for me. So this is what we are talking about, and we are serious with this. So would you like to join at some day? And last August was the time I joined the operational team.
Yeah. And I'm really happy that Lisa came with us because she's super good.
Yeah.
So I may be a bit more practical person than boys.
Yeah, and actually, talking about these, it started with the energy storage being just like an interesting idea that could you use it for the hippie commune idea, and at some point we realized that it's actually like a key part in really unlocking the renewables. So if you want to go to close to like over 50% of renewables fraction, you have to store it somehow. And batteries, like normal lithium batteries, they work fine in small scale and in some applications, and especially transportation. But when we're talking really about making 100% renewables society, the excess energy that wind and solar produces, the scale is immense. So like cheap, affordable ways to make use of it, it's really the key factor in like windmills can stand by themselves already, but if you put too much windmills in a system, you have no use for the electricity. At some point it will become rubbish, and we want to take that rubbish in, and actually it's really key in unlocking a cleaner future.
Yeah, the electric grid will collapse like after 20% of wind power in it.
Now, you guys have been working on this problem, you said, for years and years. I'm sure it's been super hard to do the science, the math, the engineering to figure this out. But now you're entering this new phase of your business, right, where you've kind of figured it out. You're testing it right now, but now you have to sell that idea to other people. And when I heard about you guys from our viewer, I went on your website and I saw your little video, and I was skeptical. I was like, they're showing windmills and solar panels. It goes into the ground. It does some magic thing. And then what? No, these guys are full of it. It doesn't work. How has it been for you guys lately as you've been telling people in the industry about your idea? Have they been receptive? Have they understood it? Or were they like me and just like not understanding it?
Yeah, actually, I found it very weird that we have been having very positive welcoming, like almost anywhere, and that's not usually the case.
Yeah, and so people are interested. At least some are maybe skeptical, but most want to hear more about it. And then there are also many people who have heard our story and about the technology, and they are like, what can be the problem with that? Of course, there are some technical challenges, as always, when you are putting up a new technology, and to make it financially efficient, you must find the right ways. But we really believe that the itself is not a problem. So that is something we can do.
Yeah, and even I have been receiving calls from the biggest energy companies in Finland, so that's pretty much tell about it, that they are even calling us.
So how common is it to have some kind of district heating in Finland?
Yeah, it's super common. Like
I don't
90%
remember.
of buildings, at least in here, are connected to district heating network.
Yeah, maybe 90 is a bit exaggerated, but far over half of the homes are heated that way.
And even in the smaller cities, there are some kind of network in the city center.
Yeah, and like one thing I would like to mention is that district heating has a kind of a bad reputation here because it's now dirty energy. They are only burning stuff, but I think that it's a big thing in the future because now you can clean that network up like super fast.
Wait a minute. Wait a minute. You're in Finland. And I'm sorry, as an American, I picture Finland as a perfect place where everything is green. You just said you're burning stuff to heat your cities. That can't be true.
That is still very, very dirty, the heat. Like here in Tampere, it's like, I think it's 100% the heating done by burning stuff.
Historically, we've been burning a lot of peat, so drying up swamps and burning that. But now the shift is more towards burning wood chip, because forest we have a lot. It's not the best solution to burn wood, even if we have a lot of it. It's not really carbon neutral in the short term, at least.
Yeah, like if we would have a stable climate and we wouldn't have the climate crisis, it could be okay to burn some wood. But now, when we really have the crisis, I think that we only have to aim for non-combusting technologies.
So I'm just trying to think, like, I mean, around us, we have these abandoned quarries. So all of the valuable, granite or whatever has been pulled out of the quarry. And now we just have these gaping holes in the ground. And I think it's like every 2 years or something, some kid goes and jumps in the quarry and either, hits his head on the way down or drowns in the bottom of the quarry. And it's, this big tragedy. And of course, people love it because it's this big rock pool or something, but it's really a public nuisance that just kind of got left behind by the stone industry or whatever. I'm just picturing if you filled that with pipes and sand, I mean, we could probably run the neighboring towns with it. So, I mean, I think that it's amazing it's so simple. Your solution is so simple. It just has my mind racing of all of the different possibilities of where to use it because, I mean, yeah, it gets cold here in Boston. And I mean, as I look on a map, there are plenty of cities more further north than Boston. I mean, I'm thinking of Canada, obviously. It just seems like this would be a perfect fit for so many places.
And as you mentioned, I mean, New York City, Minneapolis, St. Paul, like after I talked to these guys initially, I did some research and there are cities all across America that are heated this way. So it's not anything new. You're right. It can be done and it is really efficient. That's why cities have chosen to do it. It's just that I think that we've, for so many years have been just like, well, it's just cheaper to burn oil or natural gas, but it's not. So because again, like you've said, we're not counting all of those costs into it. So yeah, this is a great solution. I'm just so excited, like Jesse said, that you guys actually did something about it because there's so many people out there who would have like, well, we figured out the solution. It's in this computer program, but see ya,
right.
But
or it would be something expensive. I mean, I could easily imagine a very similar system, a parallel universe where you're saying, okay, so we're going to take, this molten salt and we're going to store it in these big tanks or something like that. And it'd be like, molten salt, that sounds expensive and dangerous. And you'd be like, well, it is, but just pay me the money. You essentially took something, akin to that and simplified it and cheapified it down to the point where it sounds like something I could do in my spare time if I wanted to dig up my backyard.
Don't do it.
Yeah, and what you talked about, you would have already a quarry in some place close enough to the consumers, and there would be this quarry and then maybe even some side rock that we could mix up with the sand. It's not that important if it's exactly sand. We just put the pipes in, fill it. You have the hole in the ground filled, and then you have a storage that you can use to heat up the whole community. Yeah, and actually, if there's a ready quarry, that's an ideal place, since the excavation can easily be 1/3 of the costs of building the storage. So if someone has already done it, it's really beneficial if we can use it.
I think that we have quite many ideas where our storage can be practical and useful, but I'm pretty sure that we don't know yet all the applications in which we can help. So we would be glad if anybody has ideas. We would love to hear them and then judge if they are doable or not.
So just kind of a practical question. What is the surface of your storage system looks? I mean, let's say that we filled the quarry, down the street from us, with sand. Is it just like a pipe coming out of the ground and a little building, and the rest of it, could we grow trees on it and stuff like that?
Yeah, exactly. Just like that. Yeah.
Yeah, out of we can put it out of sight.
Even if it's a big enough storage, you could have a park over it. Yeah,
for example, a greenhouse on top of it would be ideal, since there will be, of course, some heat loss. So if we have something on top of it that could use it, like a greenhouse on top of it, and then of course, a small hut, let's say, even in a big system, the heat transfer, it's really a centralized one place where there's a small heat exchanger, which can even be hid underground if we want to.
I love that in just a few minutes, we've brainstormed a quarry, Ambry batteries, greenhouses. These are all people you can partner with, and these are just the few that we've come up with. It sounds like you guys could work with so many industries and so many people in the world.
Yeah.
And actually, I watched one clip of yours about solar farming with solar panels on top of the fields. Then we can combine that also there, so we have food production, clean energy,
combined
storage, and even clean energy for the society close to the fields.
This is awesome.
This really is awesome. I mean, you guys who are watching right now, you need to share this video, because there's people out there who can probably make this all happen, and we can do these things. This is totally doable. The technology you're talking about. Another thing I just want to point out is when I first was talking to you guys, I was like, well, 600 degrees, that would break most things in a couple days. But your system lasts a long time.
Yeah, we are planning that it will last 50 years. The parts that are in the sand, they really have to be very well done, and they will last a long time. Only we will have a fan that is circulating the air through the pipes. You would need to replace that in 10 years time, but it's 1 promille of the investment, so not a big thing.
So is that the only moving part?
Yeah, the fan and the water pump, and those are really inexpensive.
Wait a minute. When we go to Mars, can we use your system?
Yeah, I have been thinking that. Yeah.
I'm not surprised that you have thought that.
Yeah, because of course I have been watching a lot of videos about Elon and about his plans about going Mars.
That's where we can have our hippie commune.
Yeah, hippie commune into Mars. Yeah.
That would be great. I think that's a great place to leave it. I'm so excited that you guys are working on this problem. Thank you so much for joining us today and sharing this with our audience. I'm just super pumped about your company. I can't wait to hear back from you guys in the future about what your guys are working on. So thank you so much for joining us today.
And how can people reach out to you if they want to reach out?
Yeah, thanks a lot. Of course, they can reach out to us by going our website, polarnightenergy.com.
So, I mean, I had a wonderful time during that interview. I don't know if you can tell. This is like engineering at its finest. You're identifying cheap things to make a huge difference. And I just want to say, like, if you are like a town manager, or you know a town manager, or you're I don't know, there's so many different types of people who could use this information. I mean, if you're putting in a housing development in anywhere where it gets cold and you're going to need heat, imagine saying, oh, and the house comes with free heat or something like that. Right. Because what you could be doing is a very similar thing to, say, like a big power pack system, where you could be buying energy when it's super, super cheap, which happens all the time, especially if you're a big enough, power user.
Yeah, in fact, some grids want to give you the power if you'll just be willing to take it.
Sometimes it's
or they pay
free,
you,
or
right?
they pay you, because you're basically just going to be a big resistive heater, but instead of dumping it out into the air, which is useless, you're going to be storing it up.
Yep.
So, I mean, yeah, there's so many different possibilities. I just want this to kind of be a tool in your tool belt where you can be like, oh, hey, you know what would be great? Like with the quarries, so exciting that you could take something which is essentially an eyesore and a public danger, turn it into a power storage device.
Thank you so much to Markku, Lisa, and Tommy for this amazing interview that we got. Thank you to our Finnish viewer who found this company, because otherwise you wouldn't be hearing about it. Thank you to you guys for subscribing, because if you didn't subscribe, then when we reach out to these companies, they'd be like, don't want to talk to you.
Right.
It takes a community to get these stories out.
Really exciting. I'm so glad that they came up with this idea. It just has my mind churning. I hope you enjoyed it as well.
Yeah, make sure you share it with people that you know, because if you share it with the right person, this could change like an entire city and how they do things. So thank you for being a part of it. Thank you for watching In Depth. We'll see you next week. Now you know.